Hello everyone, I'm one of the founders of VisualLogic. Today, I'm going to talk about VisualLogic and its unique programming language, VL. Actually, there are many programming languages trying to integrate with AI, but these are all traditional programming languages. We chose a completely different path. We basically created our own programming language first. It's kind of like this. It's like a Bible, and the entire syntax is defined within it. The whole thing is about 100K in size. After completing this programming language, since it's our original creation, it integrates better with AI. It's actually very simple, yet it's a complete programming language. So this is a very big feature. With it then, we can construct a new AI programming environment. This language has a very big feature. It's actually component-based. It's programming oriented towards components. You can see, all these are its components, various components, right? Starting from here. This document, you can actually download it from Git. After having that programming language, we created a set that fully corresponds to it. This IDE is quite different from existing ones. This IDE, besides what you can see, this is the language we just used. Of course, this is its playground. It's a chat panel. Through it, you can chat, generate files and code corresponding to these languages. Then it's divided into different front-end and back-end. It's layered together. It's like we're building an application. How do we integrate it from the language level? And how about from the component level? How do we do a reverse refactoring of it? Yes, these are things we consider. How is it different from existing IDEs? This IDE is a fully visual IDE. For example, let's take a look. There are many kinds of logic here. Okay, these logics are actually a new programming language. With this language, when using the graphical interface, you just need to understand the logic. You don't need to worry about syntax at all. There are many other kinds of logic here. There are lots and lots of related things. Okay, there might also be data here. You can use it too. And then there's the stage. The stage means you can see all the components here. They can all be activated or selected. For example, these things can be selected and modified in their properties. Okay, this is a language-specific visual IDE designed for it. And in this IDE, code can be converted back and forth. So these components and their properties and methods can all be interchanged. So when we're debugging or need a graphical interface, we just switch to the graphical view. This makes it really efficient. Okay, now let's take a look. After the language is done, it integrates all cloud resources. Once you combine them, you can just run it like this. Or you can export it locally. You can use it directly, no problem. This app isn't just for show or for making small demos. It can handle medium to large projects just fine, because this component is already abstracted. So when you use it to build a new app, it's very efficient. Okay, let me show you quickly. This really works. Okay, now I'll explain this PPT. Okay, why did we develop this new programming language? It's a new way to solve problems. And this approach can be quite complex and challenging. So it's like first creating a programming language, then an IDE, and then adding AI features on top of the IDE. Just this playground. So with the introduction we just had, let's talk about this PPT. Let's take a look at programming oriented towards components. And then this has multiple layers. This structure allows for parallel development during the final stages. All the core files can be developed in parallel. So when using AI to generate, the efficiency is very high. And because you're using a component-oriented approach, you save a lot on tokens. In the end, it generates front-end JS code and back-end Node or Java. It has a multi-dimensional supporting IDE. For example, it supports both code and purely graphical logic expression. This is actually quite difficult. And there's one more thing I find very useful. All our documents, the core is actually this VL syntax. This syntax is like a Bible, and what's good about it? As long as AI inputs this syntax, it can generate code in this syntax. It can also interpret any code based on this syntax, making it easy to learn or practice. Or to understand, it becomes very easy, because there's only one set of documentation. Next, let's talk about the component-oriented. Let's first look at the left side. It's divided into 3 layers. Basically, any component is integrated with events, methods, and properties, forming a trinity. Then we break down any application into its framework. We call this .vx, which is the app. It manages top-level routing, the use of various components and modules, and back-end integration, all at this layer. Here, everything can be developed in parallel. This includes sessions, services, databases, and components. Components are actually a level lower than sessions, more fundamental, like building blocks. A session is essentially a functional module, like a form or a navigation bar. And then, sim is its theme, which is a standard file. Of course, you can change it as it has a format. Finally, we just reference the specific name, and that's it. So, this allows for parallel development, very easy to maintain. All components can be reused, everything is reusable. It's very friendly to both AI and human. The entire file structure is like this. It aims to be as clear as possible. It supports hot swapping. Let's explain this to everyone. Our code actually corresponds with this kind of code. It's just that ours is really small. For example, if we calculate it, one line can expand to 200 to 400 lines. We've seen that using our method to generate code with many components, they all convert to code when compiled. So this greatly compresses the size. And here's our interface, as you just saw. It's very clear on top, like there's stage, logic, vocode, and DB. Just like DB, like MQ and Redis, including socket. All these are abstracted into backend components. You can use them direct, and once you use them, we connect to cloud computing. And how much you generate, it's pay as you go. You pay based on what you generate. Okay, your maintenance costs are really low because your backend is fully cloud connected. You don't have to manage it, just set it up. Same goes for AI. You just need to design your app. No need to manage backend maintenance or worry about token usage. This is quite different from some modern practices. What we have here is already done. So now, our core focus is on 3 layers of invention. The first layer is the invention of the language layer. We've developed a language for component-oriented programming. It's component-based, with attributes, implementations, and methods. This is quite different from current languages. We use a minimalist approach with just one. Then on top of this language, we developed an IDE. This IDE can convert back and forth with it's a direct conversion, but it's not line-by-line text, it's graphical. Then on top of this IDE, we added a layer of AI. This means AI can be used to automatically generate this language. Generating the language means generating the visual IDE, so its efficiency is very high because it's parallel. Its development dimension was originally intended to be done through this component-based programming approach. So its dimensions are also quite high. Maybe think for example, it used to be considered that linear programming it's all line-by-line code. Now we're doing component-based programming. You see it as one line, but its dimension is actually high because it's two-dimensional, so its speed is very high. And it saves a lot of tokens. So are there any limits on enterprise scalability? There's a document for this. It's almost in a very good state. This is our comparison with other existing AI products. Actually, in every aspect, we're ahead. Whether it's learning cost, usage cost, fees, generation efficiency, or maintenance cost, we're much lower. Thank you, everyone.